for streaming. In theory.
In principle.
In principle, if this technology can be trusted, which I don't think it can. It is the
Never trust a robot. That is the fourth
it's the
Asimov
two
law.
bald spaceman edition. Let me know when you can see Daniel saying hello, guys. I don't know if that means that you're seeing us live. They see us. All right.
There we go.
Don't forget to say hi. Hurry, say hi. Now's your chance, and then I'll say hi back to you. But kill that, man. So this so far has been a complete and total disaster.
What is that? Oh, a microphone.
It's a microphone. It's not necessarily that it's a fancy microphone, but it is a condenser microphone that's really designed for picking up the audios and for the voice. But it's analog, and so I'm going into a preamp, and then the preamp is going into an interface into the computer, and somewhere there's audio and the drivers, and they don't make drivers for the M audio interface that I have anymore. And so I'm back to the old Blue Snowball, which
Nice.
it's not nice. It's
At the radio station where I record my podcast, they have a beast, a microphone from the 60s.
yeah.
It seriously weighs like 30 pounds and sits on a table, and it's like 2 feet tall. And I begged them for my radio show to be able to use that microphone just because it's larger than my face.
But no,
They said it doesn't work. It's just sitting there in a corner.
it's just there for show. But another piece of gear that I got, which is pretty sweet, is this.
Ooh.
So this just came in yesterday, and this is I was gonna do like an unboxing, but huge thank you to YouTube, because if you recall, I went to YouTube back in December. They taught us how to use the YouTube, fed us, let us interact with each other at the YouTube space in Toronto, and then as a special reward in the end, gave us a gift certificate at a camera shop in Toronto. And instead of blowing the money right away, I waited and pounced on a camera that I've had my eye on for a long time. So goodbye, old Canon. Hello, GH5, which like literally just came out. It's sweet. It does 4K. It'll do 180 frames a second slow-mo. So it'll do all kinds of really cool stuff. I'm really, really excited. So we're going to shoot some episodes of The Guide to Space like today, if it stops raining badly. And so you'll get a chance to see. And then it's going to suck, and we'll have to figure it out, and then we'll get there. I'm going to say hi to a bunch of people. Hello to So Extra. Actually, it's asterisk, 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 apostrophe So Extra. Alex Economou, Andy Smith, Arnold Post, Billy Gordon, Carolyn B, Kath74, Citizen Gold, Connor Lennon, Daniel McCool, Dusty Reichwin, Ilid Avron, Endo, Eric Bennett, Galaxia, Giselle Severin, Graham Walbridge, Granville White, Greg Nickel, Guido Bibra, Henrik Bo Anderson, Hugo Burnham, James Haney, James Belts, John Gallant, John Suffield, John Victor, Julius Stanonis.
Too many Johns.
Too many Johns. Julian Brennan. It's in the J's. Linda Sadek, Malcolm Bond, Michael Jobin, Nancy Graziano, Paul Gracie, Paul M. Sutter, who's here in the show as well, Peter Quinn, Peter Schultz, Arnstro, Refurio Anacro, Relocat 100, Ronnie Pearson, Sev Dust Bunny, Skinniest Tuna, Stephen Hawkins, Sturves, The Goat, Thomas Traniker, Tony Raggett, William Vanderbeek, William Hutchings, and Zapfan. You always get the final word, Zapfan. Well played.
That's why he chose his username.
That's exactly right, and that's why asterisk picked theirs as well. Cool. So it's just me and Paul today.
That's not a bad thing.
It's not a bad thing. So in a second, I will actually start the show officially, and then we'll go into what is going to be a chill, just relaxing episode of the Guide to Space.
I won't get excited at all.
Of the Weekly Space Hangout. Sorry, you won't get it. All right. Let's just start this thing up then. Here we go. And then, oh, it's Dr. Pamela Gay. It says you are. That's not true. Hold on.
I'll take it.
There we
She's
go. Paul
very
Sutter.
smart and well respected and highly regarded and advanced in her field. So,
all right, here we go. Hello, everyone, and welcome to the Weekly Space Hangout for Friday, April 7th, 2017. I'm Fraser Cain, publisher of Universe Today. This week, we're going to be talking about black holes, as usual. What was the term you used, Paul?
The Furbies?
Furbies.
Yeah,
Furbies.
I love and hate that term.
Fast radio bursts. And we're going to be talking about, of course, the SpaceX relaunch. So that's all coming up. It's just me and Dr. Paul Sutter today.
Special edition.
Special edition. Just the two of us. A very special episode of the Weekly Space Hangout.
We can make it if we try.
All right. Well, let us start with we'll do what I think is the most important story last. We'll tackle the other ones first, and because I think we're going to spend a goodly portion of the show just arguing about the future of human spaceflight. Why don't you introduce your story about black holes, and we'll go from there.
Yeah, so black holes, and especially supermassive black holes, these are millions or billions or even tens of billions of times more massive than our own sun. They sit in the heart or it's thought that they sit in the heart of every single galaxy in the universe. Pretty big beasts, pretty hard to nudge, but wouldn't you know it, nature is good at moving things, even very big things. And what we've spotted is what we think is a supermassive black hole ejected from its host galaxy. I think by the time we've spotted it, it's already something like 15,000 light years away from its former home. And that's a lot of energy. That is not an easy thing to do, to eject a multi-billion solar mass object out of the gravitational well of a galaxy. And what we think happened, of course, and it's usually in astronomy, we don't have much idea of what happened, but our best guess for this scenario was that two galaxies merged together. And when galaxies merge, their supermassive black holes at their cores find each other in the core of the newly merged galaxy, and they start to coalesce around each other. They start to orbit in. And as they orbit around each other, they start to wave spacetime. They start emitting gravitational waves, gravitational radiation. And this actually pulls energy out of the system, which is what allows the black holes to get ever closer together and eventually coalesce and form a super duper supermassive black hole. A super duper massive black hole.
Right.
And but if one of the black holes is much larger than the other, just, random chance, one of them is very much larger, then the gravitational waves emitted in one direction will be a little bit stronger than the gravitational waves emitted in the other. And so by the time the black holes eventually merge and coalesce into a single object, there's an excess of gravitational energy on one side that is missing from the other. So that is literally a gravitational force that it can push the black hole. Maybe it just nudges it sometimes. Maybe if there's enough energy, it can completely kick the black hole out of the newly merged galaxy, which is what we think happened here.
It's interesting to me that you can get what's equivalent of like a three-body interaction with only two bodies, right? Like to get those kinds of kickouts, you've got to have like a planet and then a
little something else.
Yeah, something else that kicks something into some kind of ejection orbit. But in this case,
So if you ever wondered, is Einstein right, or do we really live in a Newtonian universe? Here's another piece of evidence this would never happen in pure Newtonian physics.
Take that, Newton.
Take that, Isaac. It's the presence of the gravitational waves that leads to an anisotropy, there's different physics happening in different directions along this physical system, and that leads to this very strange setup.
That's interesting. So really though, you do need that distinctive difference in mass between those colliding supermassive black holes. Do you know like how much more massive the kicker has to be?
Yeah, I actually don't remember the precise number when I was reading the papers, the theoretical papers on this. Again, this is just a theoretical mechanism. This is something we've explored in mathematics and simulations here, and this is potentially an explanation for the scenario we just happened to observe recently. We don't know for sure if this actually happens in nature, or if our calculations are wrong. I want to say it was something like a 10 to 1 or 100 to 1 mass ratio in order for this kind of gravitational shotgun effect.
I mean, I'm thinking about the future collision between the Milky Way and Andromeda. Ours is 4.1 million times the mass of the sun. Andromeda's is 100 plus million times, 140 million times the mass of the sun. So a huge discrepancy.
Right.
Are we going to lose our...
Well, that's a good question, because it appears that black holes, supermassive black holes getting ejected from the galaxies is a rare thing. I mean, this is the first one we've ever spotted, and we've been looking at galaxies for 100 years now. So it must be a very rare event. So either you need an extreme mass ratio that's going to be a very rare coincidental setup, or it's not just the mass ratio that's involved, that it's the particular angle and velocities that the black holes encounter each other, or maybe there's some extra stuff, the accretion disks are adding their influence to it. So it appears to be a very complicated and a very rare scenario. So I would say, if I'm just a betting guy, I would bet that we're not going to lose our supermassive black hole in the collision.
All right. Well, that's good. And I know, like...
Because you're friends with Sagittarius A star.
That's the thing, right?
Got to know it. We're about to take its picture. That's cool. Yeah. And so it would suck to lose it in 5 million years when we just got around to taking its picture.
Yeah, exactly. And so you feel like a sense of camaraderie with... It's our supermassive black hole.
It may be a pain in the neck. May mean pain in the neck, but it's our pain in the neck.
Yeah, exactly. I got a couple of questions here. It's good. We got some time. So Arjun wants to know, could this be the reason why some galaxies don't have a supermassive black hole at their center?
Yeah, obviously. And in some cases, we think if there's, say, 2 galaxies have recently merged and the black holes are still in that process of coalescing, and then a third galaxy comes winging in, and you add a third black hole to the mix, then you get those gravitational instabilities that you were talking about earlier, where one, if not all of the black holes can just get scattered out of their host galaxy.
Yeah. Let's see. This one comes from Malcolm Bond. Do black holes have to be spherical? So I think this is this is a more general question just about black holes. What defines the I mean, it's so many levels, right? But are they spheres or are they flattened spheres?
It depends on how fast they're spinning. So the simplest kind of black hole in the universe, a non-rotating, uncharged black hole, will be a perfect sphere. But if it is very rapidly spinning, it does get a little plump around the edges. And in addition to that, a spinning black hole creates a region outside the event horizon called the ergosphere, which is a region that is literally dragging space-time around in a circle. So you can approach the black hole, and you're not in the event horizon, but even though you want to stay still, you'll get pulled in a circle. You'll get pulled in orbit around that black hole, even if you don't want to.
Very cool. All right, well, let's move on to the second story that I queued up with you this week, and this is the Furbies.
Furbies, the love-hate the name here. We'll just go with it. Fast radio bursts, or FRBs, or Furbies. These are a series of 2 or 3 dozen or so detections using radio telescopes spread out over the past 20, 30 years. They were actually first spotted in archival data. So it's not like astronomers on the scene when they're doing their observing run notice something funny. They were just collecting data all night long, looking for other stuff. And then later on, in some cases, decades later, some other astronomer will be searching through the data and spot these weird signals. They're very, very brief. They last milliseconds. So they're incredibly short. They're incredibly bright. So they're incredibly loud in radio. And they seem to come from all over the place. And in order to make a very strong radio source that's pinpointed in a very small region of the sky, you need a lot of energy. And so you might think, okay, maybe it's related to supernova. Maybe it's related to blazars. Maybe it's related to something else. But when these appear on the sky, they're not necessarily connected to any known galaxies. They don't appear to come from any particular region. They definitely don't always come from inside the plane of the Milky Way. So we know they're coming from outside the Milky Way, somewhere in the distant universe. They're not connected to any visible counterpart. So it's not like we see a supernova going off and then we get a Furby signal at the same time. It's a mystery. Mm-hmm. We really don't know. And one possible resolution to the mystery is, you idiots, it's something happening on Earth.
Right.
And just because you're an astronomer, you think it's coming from space.
And that was the big announcement that came this week. And we posted people accuse us of a clickbaity title on Universe Today.
Because you used extraterrestrial.
Yeah.
But you know what? That's legit.
Well, absolutely. Legit. And anyone that we explained it to. So our title was Extraterrestrial Origin of Fast Radio Burst Phenomenon Confirmed. Yeah. Extra meaning outside, terrestrial meaning Earth. And this was a big controversy. Like stupid Earth has
it turns out signals. We like our radio.
Yeah. Has caused problems. I mean, even like the WOW signal is thought has a high potential chance that it could have been some kind of signal from Earth or bounced off of some Earth-based satellite or some, there's some local origin. And so, I mean, are there things that could cause these kinds of signals and that could be coming from Earth? I mean,
yes. We thought that the terrestrial origin was because we've actually seen this before, especially with the Parkes Observatory, which is one of the main sources down in Australia where we're detecting these fast radio bursts. There was a series of detections that they called peritons, which were related to fast radio bursts, but a little bit distinct. That turned out to be the microwave in the visitor center. That they were catching some errant signals from that. So there's military satellites, there's communications gear, there's someone who forgot to turn off their cell phone when they took the observatory tour, or and it's just in their pocket buzzing away. Yeah. If you try to visit a radio telescope and to take a tour, these are radio quiet zones. Like you have to give up your cell phone. There's no microwaves allowed nearby. Everything has to be shielded and well protected.
Yep.
There are plenty of, and this is something that radio astronomers are constantly fighting, is sources of terrestrial interference, because we're trying to get the signal from the sky, and there's so much noise happening on Earth that we're trying to avoid it. So are fast radio bursts terrestrial in origin? Maybe some of them are, but at least these ones that were recently observed are not. These are definitely coming from outside the Earth.
All right, so let's just talk a bit about possible explanations. I'll get to the fun one at the very end, but let's talk about like some potential explanations for what these could be. We got a little time. I mean, I'm imagining something catastrophic happening in a moment.
Mm-hmm. Yeah, because it's millisecond. So, it's happening like that. It's pouring in a lot of energy because otherwise you wouldn't get that loud of a signal in the radio. And it's involving radio waves. So whatever generating it has to involve the motion of charged particles to actually emit electromagnetic radiation in the radio spectrum.
They're coming from fairly distant locations.
Yeah, so we were wondering maybe that it's just junk happening in our Milky Way, but they come from all over the sky.
Right.
So they're not just constricted to just the disk of our own Milky Way. They come from all over, which means they have to be coming from outside our own galaxy.
But they're not necessarily. I mean, they're matching them up with galaxies, but those galaxies aren't necessarily
doing
anything in any special way. Yeah,
it's not like they're a quasar.
Yeah,
and you're like, oh wow, there's a black hole that's feeding and it's becoming a quasar, and like, oh, it's burping every once in a while and that's making a Furby.
Yeah.
No, it's just like, totally mediocre, run of the mill galaxies. It's not like they're having supernova happening at the same time that we can detect. There's no pulsar emission that seems to be correlated with it. These fast radio bursts don't repeat. I think there's only been one case where it's repeated, and that time it repeated once or something like that.
Yep.
So in general, they're like blip on the sky.
Yep.
And you race with all the other telescopes in the world, like what the heck just happened? And the galaxy is just like, oh no, I'm not
there
doing
have been some like afterglow, like they fade away a little, over some time. So that's a possibility. But I mean, it's funny, right? Because you think about something that could generate that loud of a signal, but in the radio spectrum. I mean, we look at things like quasars, radio galaxies. I mean, it's an orientation of the quasar that allows us to see. So it could be something like that.
It could be something, but the radio loud stuff in our universe, the stuff that really screams in the radio, tends to be very broad band, where you can tune your receiver across a bunch of frequencies and still pick it up. These fast radio bursts, in addition to being very short, just a few milliseconds, they're incredibly narrow. They're on like a very, very specific set of frequencies.
Yeah.
So it could be something like a supernova going off, but instead of being isotropic, just kind of blows up in one direction, makes it look like a cylinder, and we're just getting the blast face on. That would have maybe the right time scales. It could be something like an incredibly powerful magnetar, a magnetized pulsar, and the jet just happens to spin up in just the right way and flash over us just once, and then something happens and it's not able to repeat itself. I mean, there are a handful of semi-plausible to quasi-plausible physical mechanisms for generating this, but it's one of these things in astronomy where we only have a couple dozen samples and don't have a lot of data, so we don't have a lot of information to base our theoretical models on.
So the most exotic answer that I've heard that is fascinating, it can't be ruled out, is that we're seeing extragalactic civilizations. Now it is the true extraterrestrials, and they are zapping or sending communication signals back and forth between their worlds, and that we're happening to get caught in the perfect, blast as that signal is being sent from place to place, or that we're seeing them powering their spaceships with their gigantic microwave space towers that are blasting the solar sail and sending power to this spaceship as it cruises from world to world in this galactic civilization. Which
that's fun to talk about. But like once you involve in intelligent actors, you can create any kind of signal you want,
and all of the things, right? Pulsars, quasars, each one of them spent some time being thought to be little green men.
Right. And it's just like, because intelligent actors can make any kind of signal you want, your power to do science, your power to test that as a hypothesis actually shrinks down to nothing. If you're going to claim it's aliens, you might as well say it's angels, because scientifically it's at the same level. So, it doesn't mean it's not true.
Right.
It means scientifically we can't address that question.
Right. There you go. Our intro says it was dissipating Cherenkov radiation from starships using Alcubierre drives. Perfect.
Yeah, that's not, none of those are a thing. Well, Cherenkov radiation is a thing. Okay, I'll give you that one.
And starships aren't a thing, and Alcubierre drives aren't a thing yet.
No, they're not going to be a thing. They're right up there with wormholes. You need negative mass
and EM drives.
Oh, do you want me to talk about EM drives again?
If we have time, we could very well talk about if people want us to talk about EM drives. So we've really just got one more story, and then I think we'll kick over into answering people's questions, and we'll answer anything we want and you want. So we got some time on our hands. So last week, Morgan and I talked about the launch of the used SpaceX rocket, and that is, you know, to sort of understate, it's one of the most important accomplishments in human space exploration, or just in space exploration in general. Rocketry, unbelievable accomplishment. That was awesome. The new piece of news is that SpaceX has released more information on their Falcon Heavy. And this is, of course, going to be their heavy lift vehicle that's going to be launching sometime later this year. It was supposed to launch last year, but, you know, Musk time. So the cool thing, you know, we knew that the Falcon Heavy was going to be, parts of it were going to be reusable, and now we've got a little bit more information about what's going to happen with that. So I'm putting up the picture of what the Falcon Heavy is going to look like here on the screen. You can see it's got, looks like 3 boosters. Actually, the middle one is going to be sort of a toughened up booster, but the plan is that they're going to be launching these 2 secondary boosters are actually going to be reused for that first launch. They're going to be reused rockets from previous launches. They're going to use those reuse, you know, some of the previously launched. The flight tested are going to be launching. And then the other part is this upper stage here. And the plan is, right now there have been no plans to launch upper stage, to reuse and recapture upper stages, but now we have a possibility that this upper stage is going to be used too. So imagine what could very well be happening when the Falcon Heavy launches. Things going to lift off into space, and then it's going to dismantle itself. It's going to disassemble itself into 4 parts and the fairing, and they'll all come back to Earth. The 3 boosters.
Oh, it's like a reverse Voltron.
Exactly. The 3 parts are going to sort of disconnect themselves, return back to Earth. The upper stage is going to come back to Earth, and the fairing is going to be captured with parachutes or something and essentially be reusable. So not only are we looking at something that's going to be reusable, I mean, something that's just going to be used again and again and again. It's pretty exciting. So that is that was the new additional announcement that happened just a couple of days ago.
I think that's the really cool thing is when people ask, like, you know, what value is there in space? Like, what useful stuff can we do in space? Well, the answer is if we make access to space really, really cheap, which is exactly what SpaceX is pushing for. If you make it cheap, people will come up with surprising, creative ways, things that aren't even on our radar now, where you couldn't even imagine it. There's some genius sitting around in a basement saying, "Man, if I could launch a payload at X dollars per pound, I could do this mind-blowing thing that no one's ever thought of.
Yeah,
I could create markets." This happens all the time with technological development. Once you make something cheap, people come up with ways, very creative ways to exploit it, to do very interesting and useful and cool things. So I'm more of the build it, you will come kind of camp. Like, let's make it cheap, and then we'll see all the cool stuff that will happen.
Yeah. Absolutely. And I mean, when you look at things like, I'm just playing the video for how this thing is going to work. I don't know if it's going to show the full separation, but, you know, this idea that we're going to get internet for all, right? That you're going to have internet, what is Elon Musk thinking of? Like maybe 5,000 satellites in space, all of which are beaming gigabit internet back down to Earth, and you don't need a wired internet connection anymore, right? Or I mean, just like other kinds of telescopes, and even just when you think about having the the requirements for just human exploration of the solar system. You know, that's going to require so much gear and water and just material, and to have these all
Matt Damon's.
Yeah, Matt Damon's and potatoes, right?
We need at least 5 of them.
Exactly. And for all this stuff to go just up into space relatively inexpensively, and just, you know, and so I think you're exactly right. We just don't know all the things that we're going to need. Let's just...
And we can't know.
And we can't know, yeah.
You can't sit down with a pencil and paper and try to figure it out. This is something that just normal human creativity and ingenuity will continue to surprise us.
Yeah. And so that is, I think, and I've been thinking a lot, you know, I just wrote up a video. We're going to record this later on today, be the next guide to space video that we do on the channel, about just what is the real advantage of this reusability. I mean, the cost is one thing for sure, that you're going to bring down the cost of rockets a bit, you know, 30%, whatever, you know, when you really look at the reuse. But it's the reliability, right? That you're going to launch the same rocket again and again and again, and then you're going to see how this thing wears down. Where is the maintenance? Like, is it the landing struts? Right. Is it the rocket nozzle? What is the part of it that wasn't built strongly enough? And that's never happened before. We've never had really a vehicle that had that kind of reusability and a maintenance.
Right. These are questions we've never really had to answer before.
Yeah. Where does an Atlas V rocket wear down? We don't know, because we throw them out after using them once.
And we pretty much totally rebuild the space shuttle.
And the space shuttle, yeah, exactly. It's just completely rebuilt. So Arjun is saying, you know, can we get the same reliability of the Soyuz capsules? That's a great example, right? The Soyuz have been the most reliable spacecraft when you look at it. They've been used for 50 years, just the same... So, you know, the same capsule just used, the same design used just again and again and again. So I'm pretty excited. And, you know, I know Elon Musk always gets his free advertisement here on the show.
That boy needs it.
He does. He needs our help.
He needs the Fraser bump.
Yeah.
You know, we're really rooting for you.
Exactly. Let's help that young upstart. You know,
I heard he's got a Kickstarter campaign.
Live his dreams. So, Matt 2893 saying, right, I drive the same car to work day after day. Exactly. And the car that you drive is reliable because whoever made your car figured out where it wears down and made those parts better. And I think that's really the great advantage to this. So,
and think of all the parts of modern society that assume that cars are cheap and ubiquitous.
Yeah.
That would be totally unimaginable to someone living 100 or 150 years ago.
Yeah.
And as soon as you make cars cheap, very, very interesting things happen, and other things become enabled once you assume that cars are cheap and ubiquitous.
Yeah. And then we all just depend on our inexpensive rocket flights. So we've got about another, maybe 20 minutes or so. So we've got some questions that people got. So this one comes from our Ricardo Jose Jacob. Does SpaceX break other space agencies using this rocket? So what do you think? Do you think that other rocket agencies, United Launch Alliance, guys like that, are going to be in trouble?
I don't know if they're not necessarily in trouble. I would bet they're keeping a very, very close eye on what SpaceX does, because they have a certain business model, and their model's been working for the past few decades. And this is essentially a disruptor. This is the Uber of spaceflight.
Yeah.
And everyone's just like, how is this going to shake down? Are they going to adapt? Are they going to try to do their own? Or are they going to maybe pivot and specialize in other things? Maybe they'll specialize in the capsules. Like I know Elon has his own capsule. Maybe ULA is going to, they're going to leverage off of SpaceX's engines and rocketry to do something else related to spaceflight.
Yeah.
Or maybe they'll copy and become a competitor. Whenever an existing dominant company is facing a rising competitor, there's a variety of responses available. And it'll just be interesting to watch over the next few years and decades which one of those responses they pick.
I mean, one of the things that's interesting is that ULA is working on a rocket with some reusable components. They're working on this thing called the Vulcan, I think it's called. And the plan is that it'll have sort of this main fuel tank, and it's going to have these rockets that are strapped onto the side of this fuel tank. And the rockets are actually Blue Origin rockets, so the same ones are going to be on the New Glenn. And the rocket's going to lift off, and then these boosters, these engines, are going to peel away off of the fuel tank, and then return to Earth. They're going to be captured by helicopter, and then the whole thing will be reassembled because the engines themselves are sort of the most expensive part of the process. So, I mean, maybe sounds good, but if you, it's hard to beat a rocket coming back, landing on its launch pad, and another cargo.
Unless it turns out that there's a lot of wear and tear in that event. You have to rebuild the landing struts, and you have to repair the fairing every time. But the engine's good to go. But you have to end up doing refurbishing. Maybe it's cheaper just to chuck all the stuff and keep the engine every time.
Yeah, it's true. I mean, that is a real possibility, that the fuel tanks are so large and they have to be built so thin and delicately that it could very well be that you cannot get much reuse out of a fuel tank. Although SpaceX just launched a rocket twice, so
do you get a discount if you use one of their used boosters?
Yeah, you do.
Excellent.
Yeah. One of their flight tested, flight proven rockets.
Flight proven.
Yeah.
Ooh.
Yeah. Then you do get a bit of a discount, but I don't think it's going to be that much. I think it's going to be like a 30% discount. I think, which is nothing to sneeze at.
Hey, I mean, I'll buy a shirt if it's 30% off.
Yeah, exactly. So this is kind of on a different vein, but this comes from Malcolm Bond. How much would a space elevator cost? And what could it lift into space? So where do you put space elevators? Are they
a space elevator would cost
drive of your heart?
Yeah, a space elevator would cost infinity dollars because they're made out of materials that don't exist. I wouldn't put a space elevator at the same level as an EM drive, because EM drives are just based on physics that don't happen in our universe. A space elevator is based on materials that we don't yet have access to, but there are advances in materials all the time. I view space elevators as more of a long-term engineering challenge rather than a fundamental physics challenge.
Right.
And whether a space elevator makes sense for Earth or more sense for something like the Moon or Mars, where there's no atmosphere and there's no gravity, or the gravitational well is shallower and there's no atmosphere. I can see the space elevators playing a role there in the far, 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 far future, very far. It's not happening tomorrow or the day after tomorrow.
Yeah, I mean, you need to, in order to build a space elevator, you've got to be able to weave together, theoretically, some kind of carbon nanotubes into structures that are longer than a couple of centimeters, which they can only do today. And then you've got to find an asteroid, bring it into orbit, attach nanotube manufacturing facilities onto it, and have those, bring a cable down to Earth. It
Yeah,
is.
when bringing an asteroid into Earth orbit is the easiest part
Yeah.
of your technological solution, then
Yeah.
you know you've got some serious issues.
Yeah.
But no, you need something that's has incredible tensile strength, because there's going to be an immense amount of tension on certain segments of the cable, but it also has to be incredibly flexible, and so it needs a lot of shear strength. It's a hard thing. I feel bad for my engineering friends who actually have to solve problems like that.
Right, right, right. Now you could go to other places. I mean, you go to the moon, and you could use spectra. I mean, you can use Kevlar fiber to make a space elevator work from the moon. Mars would be possible. It's
but
just
maybe
the
in
Earth.
the end, it's always going to be cheaper to have reusable rockets.
Or some other way. I like rail guns, things like that.
Just jumping really high.
Just jumping really high. Yeah, exactly.
I think we should build a rail gun into the Mariner Valley on Mars.
Yeah, there you go.
Just make it happen.
Arjun wants to know, would the Falcon Heavy be able to lift larger loads than anyone else? Yeah, so I can answer this, kinda. The Falcon Heavy will do 64,000 kilograms, which is 141,000 pounds, into low Earth orbit. The Space Shuttle could do 24,000 kilograms. The Delta IV Heavy can do 22,560 kilograms. Now, the Saturn V could do 130,000 kilograms. So the Falcon Heavy still is only half as powerful as the Saturn V is. The interplanetary transport ship will be able to do 300,000 kilograms into low Earth orbit in its reusable mode. So it'll launch 300,000 kilograms into low Earth orbit and then return to the landing pad and go from there. I don't know the lift capability of the SLS. It's going to be more than the Falcon Heavy, and the New Glenn is going to be sort of in the same class. So we're looking at a whole new set of launchers that are in this 60 to 130,000 kilograms. It's a pretty cool time for if you want to launch, I don't know, a building or a mountain or something into space. Now's your time.
Don't let your dreams be dreams.
Don't let your dreams be dreams. Put it on a rocket and just send it. I think we were talking about that in Astronomy Cast one day, that you could take like the Keck Observatory and just stick it on a Falcon Heavy and just loft it into space.
The Keck Space Telescope.
Yeah, the Keck Space Telescope. It's already a powerful telescope. Why not put a 10-meter telescope in orbit? I mean, you couldn't do anything with it. You know, it would be drifting helplessly in space. But it would
have to send the astronomers with it.
Yeah,
so they can look through the eyepiece.
Look through the eyepiece. Yeah, exactly. It would be the most powerful space telescope ever launched, though. Malcolm Bond wants to know, what about high altitude balloons to lift things to space?
High altitude balloons can take you very, very far in the Earth's atmosphere, but as soon as the density of whatever you filled your balloon with is equal to the density of the surrounding atmosphere, buoyancy stops and you stop going any higher. So you can use balloons to get like off the ground, and then you attach a rocket to that to finish the way out into space. Remember, the challenge for getting stuff into space isn't necessarily the height. You can build a backyard rocket that gets the rocket up to the edge of space, but then it's going to come right back down. The challenge, especially for going into orbit, is to get the speed necessary for orbit. So you have to reach a certain speed in order to go around the Earth. You have to reach a certain speed in order to escape the gravitational pull of the Earth. And for that, you have to get really, really fast. And a high altitude balloon can get you the height, but it's not going to get you the speed you need.
And I've heard some pretty fascinating ideas, like building some kind of high altitude launch platform. So you build like the equivalent of what SpaceX launches from, but instead build it on some kind of flying supercarrier, like from Shield that is
That one.
Yeah, but
a documentary film.
Yeah, exactly. Yeah, no, the Avengers was a documentary, and so you fly the thing really high altitude, and then you fire rockets off the top of it, and then you don't have to worry about the air resistance going up through the Earth's atmosphere. You're above most of the atmosphere, but you still have to go 27,000 kilometers per hour that way. That's your challenge. It's the that way part.
Yep.
Larry Beckham wants to know, what is the largest telescope that actually has an eyepiece?
I saw that question.
Yeah.
I have no idea.
Yeah.
There are some very, very large, especially if you go back to some classical observatories built in the 1600s all the way up through the early 1900s. Like Hubble did all of his work discovering the expansion of the universe at Mount Wilson using an eyepiece.
And that telescope's still there, isn't it?
And that telescope's still there. And at the time, that was the biggest one at the time. I want to say 10 meters, but I think that's wrong. And that had a straight up eyepiece, and he had a little chair, and he hunched over.
Yeah, it wouldn't be 10 meters. I mean, 10 meters is the size of the CAC, right? But like 100.
I'm looking it up right now.
100 something centimeters, like a 1.5 meter, like the size of the Hubble space. But they use a lot of refractors back then as well, and not just reflectors. So
yeah.
So then those two sizes aren't the same. Refurio and Acro asks, if the space elevators are next century, what about skyhooks?
I don't know too much about skyhooks.
So you've got some kind of rotating tether that's part of it is way outside of the atmosphere, part that kind of comes down through the atmosphere, and the whole thing is rotating, and you have to reboost it from time to time. It's in orbit.
Yeah.
And then as that hook comes down, you can then catch a lift that pulls the whole thing down, and then you can boost it back up, so that you've got. I
guess you lift for space, so you're relying on like the angular momentum of the hook to boost you up.
Yeah.
But then there's a lot, like you said, there's a lot of drag through the atmosphere.
Yeah. Have you read the book Seven Eves?
I have not.
Yeah. So in Seven Eves,
it's on my list.
It's a first half is wonderful. Second half, actually, I like the second half too. A lot of people thought the second half was weaker, but the cool thing about this is how they've built essentially an orbital civilization, and a lot of it is all based on momentum, that you've got rotating. If you want to move from one colony to another colony, you catch a ride on some kind of rotating momentum transfer that gives you a speed in a new velocity that you're looking, in a new vector that you're trying to get to. And so you may come in on one, you get caught, pulled around, and then released in some other direction, which is pretty fascinating.
Sure, do it. Whatever.
Yeah.
I'm seeing it is the Mount Wilson Observatory, a 100-inch telescope, which is 2.5 meters. Yeah. I was only off by a factor of 4. Good enough for astronomy.
Right. People were mentioning my microphone. This is why I tried to get this thing going, because this is all analog, baby. But this thing is not to be trusted. And if it's doing the audio problems, screaming, then I might as well just go back to my other microphone. I have a graveyard of microphones in front of me, really. What else? Let's get another question here. Larry Beckham is saying to check out Isaac Arthur's show on Skyhooks. He said that it is possible. Well, there you go. If Isaac Arthur says it's possible, then it's got to be possible. Have you seen Isaac's show?
Never trust a man with 2 first names. That's all I'm saying.
That's all you're saying. Paul, Matt.
Where your last name is your first is can be read as know what I'm saying.
I've got two last names.
Fraser and Cain. That's right.
Yeah. Yeah. So what does that mean?
It means you're double trustable.
Exactly. Malcolm Baum wants to know how far off in time when men can inhabit the moon. People can inhabit the moon. When will we be on the moon?
We're just gonna send men there.
Yeah.
And then they'll die out in a generation. Yeah. And that was the last time we'll ever do that. Living there, I mean, oh gosh. Going to the moon, going to the Mars, I can see it, over the next few decades. It's very plausible with reasonable projections of our current technological capabilities and our ability to raise funds, our wealth in our society to do it. But colonies on the moon and on Mars, where the sense of living, as in people are actually being born, living their entire lives, and then dying, that is so challenging. And just look, I always go back to the Antarctic research stations. Our South Pole Research Station is the most expensive science project funded by the National Science Foundation. It is ridiculously expensive. And that's already on the Earth. Mm-hmm. Like, you just fly planes there or drive trucks there, and there's water all over the place.
You could ski there.
You could ski there if you were so. You could have dogs take you there, if you were so inclined. It's just the enormous infrastructure costs. It's not impossible, like a space elevator. It's not impossible. It's just a tremendous engineering and technological feat that I am hesitant to put any sort of date on it because it's really, really hard. But sending people in general, yeah. I could see it happening in a few decades, but living there.
Do you really want to live there? And this is the
other question.
Right.
Who are all these nutballs? Sorry, I mean I don't. Like the Mars One people.
Who are all these daring adventurers?
All these beautiful, wonderful people living wholesome lives and are full of dignity and respect and deserving of all that. That's what I meant to say. Yeah. That nutball is short for all that.
Yeah.
Like, who wants to live on Mars?
Yeah.
Mars is cold. It's red. There's no air, and the air that is there is poisonous.
Yeah. And you won't know because you're going to be living underground.
Yes.
You're going to be living like a mole underground, and that'll be your life.
The mole people in fiction are never talked about highly.
It's not an
aspiration. Right? They're not
life aspiration.
Man, I would love to be a mole person. Right? They're always a threat. Right?
They always are looking to foil our surface world plans.
Who aspires to be a mole person? That is your fate. You'll be a Mars mole person.
Yeah. And so if you want to take a shot, if you want to sort of see if you've got the right stuff, go spend a winter or two on Baffin Island in Canada. Like, go north and live on and that is still 10,000 times better than what you would be experiencing on Mars.
Although, to be fair, there are many Europeans who consider the extreme weather of North America to render it essentially uninhabitable and are surprised that people actually willingly
can we blame them?
Yeah.
No.
Yeah. I can't.
Yeah. So I think that's it. And so I really like that quote. Actually, Neil deGrasse Tyson really put the nail on the head on this one for me, which is, would you go to Mars? I'll go to Mars when Elon Musk's mother returns from her voyage to Mars. When it's safe enough for a person to do a return voyage to Mars, I'll go on a tourist trip to Mars. But
that's like, just take away the pleasantries of living on Mars, just the danger aspect. Like, half of our missions to Mars fail, and those have all been robots.
Right. And who cares about robots? Yeah. No, it would be tough. And Earth is the best. So, like, let's protect this place that we've got. It's great. PH11 wants to know how small a rocket can be and still make it into orbit. I wonder what is the smallest possible rocket.
That is a good question.
Yeah. If all it did was had to put 1 kilogram into orbit, I mean, the Sputnik was a pretty, that's sort of the smaller, on the small scale of what the rockets could be. At the end of the day, you need a certain amount of just fuel that you're going to burn and get that to get a mass into orbit.
Yep, but then you need more fuel to lift the fuel.
Yeah.
And then you need even more fuel to lift that fuel. And so there is a certain minimum you need.
Yeah, there would be a minimum size. It'd be interesting if someone...
That sounds like a homework problem.
Yeah. You going to write that down for your students?
I'm totally going to do it.
All right.
In the middle of something inappropriate. It'll be in the middle of an exam that's on something else.
Yeah. And then you'd be like, did you account for the fuel to lift that fuel into orbit? And did you account for the... How does anything even get to orbit?
It's all fiction. You heard it from me first.
No, okay, there you go. Cool. Well, I think we're sort of reaching the end of this show. Just want to remind you, big thank you to the Weekly Space Hangout crew. These are the people who really organize the community behind the scenes. This chat down here comes from the Weekly Space Hangout crew, so if you want to participate in this super secret inside chat, go ahead. Go to wshcrew.space. All right, Dr. Paul Metz-Sutter, where do people find out more?
They can find out more by following me on Twitter and Facebook at Paul Matt Sutter. Also, my website, pmsutter.com, has links to all the cool outreach and educational activities I do, including my own podcast, askaspaceman.com.
And of course, I am universetoday.com. You can also subscribe to this YouTube channel if you haven't. And the other thing I would like to encourage you to do, now Dr. Paul Metz-Sutter has a Patreon, so does a lot of the super space folk that you like. Amy Shearer Tidal has one. Isaac Arthur, who we talked about, has one. I obviously have one. And I don't know if people are aware, but there's been a sort of a bit of an apocalypse on YouTube. A lot of people are losing a lot of their advertising revenue. A lot of these sort of mid-level YouTubers are going to be going through some pretty tough times in the next little while. So if these kinds of shows, if you enjoy this kind of thing, I highly recommend that you seek out just all of the creators that you like and find out if they have some way to support them directly via Patreon, or even just to help share and subscribe and get the word out on the projects that they're working on. It makes a huge difference in our ability to do this kind of thing. So,
oh yeah, absolutely. So all of my material on YouTube, my podcast is all released Creative Commons and ad free. It's all supported. Everything I do in all of my education and outreach is supported by Patreon. I have a day job, so I can pay for my house and my food. So that's good. I just use any contributions to pay for all the extra stuff.
Yeah, absolutely. So, I mean, not necessarily us, but obviously if you want to contribute to our Patreons, patreon.com/universetoday, Patreon.
We won't tell you no.
Yeah, we won't say no. But really just take a think about the kinds of content that you're consuming on a regular basis. What are the YouTube shows that you look forward to each day that they come out or each week that they come out, and go support them, and you'll make their creators' days. Stop giving money to Marvel and Disney, and just think about people like that. So, all right, thanks everyone for watching this week's episode. Really appreciate it. We're going to be going on and doing Astronomy Cast in about 30 minutes. We're going to be talking about animals in space, specifically insects and arthropods. So
that sounds fun.
Yeah. All right. Well, we'll see you all next week.
See you, everyone.